Welcome to our PoC this year about the automated inter-carrier credit ratings using blockchain. So in this PoC, we focus on 4 areas. The first one is the inter-carrier SD-WAN orchestration by the MEF Sonata S API for the LSO. And the second part is that we do the blockchain technologies for the service industry record on the blockchain, on the DLT. Then we program the smart contract for monitoring about the service level agreement. And then we will average the credit rating amongst the carriers. Okay.
Thank you, Victor. Hi there. This is Divesh Gupta from PCCW Global. We're participating in a very exciting demo or a proof of concept here at MEF, and I'd like to share a little bit about that. So PCCW Global is providing connectivity together with our partner, wholesale carrier partner, DCConnect. And we have set up a live network where we are showing a proof of concept for provisioning of the E-line service using MEF LSO Sonata APIs. So the additional part about this this demonstration is, apart from a fully automated live network where we are provisioning services across 2 different carrier domains using the APIs, we also record transactions on a blockchain ledger technology using Corda. And we're using SLAs metric for performance monitoring. In this case, it is for service turn-up. So the time it takes for us to turn up the services is registered in different ledgers using blockchain. And that is actually used for the carrier ratings. And that is visible to the customer. So when a customer orders a link, they would be able to see in real time whether the service has been turned up in the desired time that they requested. And the other fact about this project is that Corda is a private blockchain technology. So when we register facts on the ledger, these are actually private until you actually choose to share them with the partners. So in this case, one of the customers who actually orders the link would have view of the fact that you would be able to see the carrier ratings. Whereas there is another customer on the same blockchain, but they didn't order the circuit, they wouldn't be able to see that rating. So it's private in that sense. So we're excited about the project, and I think Thomas here will be telling you more about what we're doing on the blockchain.
Thanks, Divesh. Hi, my name is Thomas Spencer. I'm with R3. We're very proud to be participants in this project. We have developed Corda, which is the underlying blockchain platform that has been used for this POC. Corda is a enterprise-grade blockchain platform that's been developed specifically for enterprise use cases. It's quite unique in that sense because it provides all of the benefits of a blockchain in terms of a distributed ledger and the ability to maintain immutable records of shared facts, data, or business logic, but to do so whilst maintaining privacy between participants and also a highly scalable platform as well. So in this project, we worked with PCCW Global and DCConnect, who built the application running on top of the platform. And now I'm going to pass over to Michael to showcase that. Thanks.
Hello, I'm Michael Rascoe, Head of Solutions at DCConnect Global, and I'm going to show you what we've done in the demo here. What we've done is provisioned a service automatically between Tencent Cloud in Beijing and a customer switch in Singapore. DCConnect carried the service from Beijing to Hong Kong, where it was passed to PCCW Global, where it was taken to Singapore and terminated into our simulated customer switch. We've used the Corda ledger to keep track of the transactions, and as Divesh mentioned, everything is private between the users, and information is only shared on a need-to-know basis. So here within the customer portal, we can see the service being ordered and provisioned, whereas on customer 2, they'll have no visibility into the same transaction. What we can see is that the service was set to be provisioned with a 200-second SLA for the provisioning period, and the service actually ended up being provisioned in 73 seconds. So that resulted in a increase of the carrier performance score or credit rating, showing that both carriers are meeting their SLAs for provisioning time. We've also done this over a live network, so it's not actually a simulation, even though there are some virtual machines running within my laptop here. But we actually ran this circuit and provisioned it live from Singapore to Beijing, and we can see that the new latency across our private tunnel is down to about 81 milliseconds, and that is from an original ping of I think about 245 going over the public internet. So we were able to cut this 250 some odd millisecond ping time in about a third in less than a minute and a half, and recording the SLA obtainment on the Corda ledger.
So hello there again. So what we saw here in the POC today is just a starting point, and we are trying to show how blockchain can be used as technology for choice for carrier operators to build trust and share facts between themselves. In this case, it's been a SLA parameter that we chose to demonstrate easily, which was for service turn-up. But you could actually apply this to any kind of contract between carriers. It could be for instance, for jitter or delay latency monitoring between active circuits on the network. It could be also for any other parameter that is chosen between within the SLA between these two partners. And if there are multiple operators involved in the same connection, then all of them can have view of the same ledger entries. And then there can be even billing settlements done based on the fact that a circuit has been turned up and turned down. So there are various other use cases where this technology can be applied. But mainly what we are trying to show here is that this is a mechanism where you could actually use it for shared facts, and they can be recorded on a ledger which is immutable, and it kind of forms the basis of providing connectivity across multiple domains, across multiple service providers. Thank you very much.